So let's explore NumPy. NumPy is a Python-based package who provides main object, which is the homogeneous multidimensional array. It also provides us with the vast collection of functions that help us with linear algebra, fast Fourier transform, and trigonometry. It also has a very sophisticated random number generation module. In the bottom section over here, we see a sample code to use NumPy. We first import the package NumPy as np and create the object np. Now, Python being an object-oriented language, you'll see a lot of similarity with Java or C++. Now over here, we say a is equal to np.arrange and a parameter 15. For the moment, ignore the second half. Just concentrate on the first half. A is equal to np.arrange 15. So you're invoking the function arrange from NumPy and we're passing a parameter 15. So what will happen over here is it will create a NumPy array with 15 elements. It will start from 0, end at 14, and it will be one-dimensional. That is, it will have just one row. Now the resultant object is again a NumPy object. So this function, reshape function, acts on the output of this function and will augment the dimensionality of the resultant NumPy array into a different one. So the output over here would be 15 elements in one row, and that is augmented into 3 rows with 5 elements each. This is very similar to what you would have already seen in Java in case if you have exposure to it. Now when you print the output, this would be the output in the terminal. Towards the right, you'll see a sample visual example of a NumPy based array. Now this is a 2-dimensional array where I have highlighted the indexes in gray. So you can see the column-based indexes range from 0 to 2 and the row-based indexes start from 0 to 10. It always starts with 0 and ends with the length of the respective column or row. Let's have a quick overview of NumPy with a couple of practical codes. We'll explore a couple of them using Spider. We'll quickly create a couple of dummy NumPy-based arrays and augment them with a couple of functionalities that are already provided. Towards the end, we'll have a basic overview of what kind of functionalities are available within NumPy and how can we leverage them in the further sections. So let's get started. We'll first import the NumPy module. Now once we have imported, let's create a dummy array. So I'll create a NumPy array as a1 is equal to np.array. And then let's pass a random list, a list of, let's say, 5 elements. Now over here, you can see that the name A1 has an array of 5 elements. You can just do a print to verify the same. There you go. You can see the elements over here. Let's do a type of A1. And you can see this will be a multi-dimensional NumPy array. Even though this has just one row, it is considered an ND array because the other dimension will have a value of 1. We can also create a multi-dimensional array using the basic functionality over here. Let's create A2 as numpy.array and we'll create a multi-dimensional array. So what we do is we nest 2 lists within each other. So we have 1, 2, 3, 4 and 5 and another list 1, 2, 3, 6. Some random numbers. Now this would be a NumPy array of this dimension where we have 2 rows with 5 columns. We can actually check the shape of a NumPy array using the shape property. Now A2 being a NumPy object, you can invoke the shape using the dot operator. I would say A2 dot shape, and you can see the shape is 2 rows and 5 columns. We can also augment this. Let's say you'll say reshape them as 5 into 2. Now I've reshaped that. This is similar to transform. You can also transpose, and then you'll see the resultant vector. You also have a lot of mathematical operations available with NumPy. So let's create another dummy array over here with some different values. So let's say we have a couple of values different over here and a couple of values different over here. All good? So we have A2 and we have A3. Both of them are a two-dimensional NumPy array with the dimension 5 into 2. Just to confirm, let's print the shape of A3 also. You can see over here, it's a 2 by 5 array. Now we can do arithmetic operations in this. Let's create a new NumPy array A4, which is a resultant of addition between A2 and A3. So A2 plus A3. I'll have the resultant matrix or array with the values added element-wise from both the NumPy arrays. You can also do a dot operation or the matrix multiplication. So for that you'll say A2 dot A3. But the basic rule of matrix multiplication or array multiplication is the number of rows over here should be equal to the number of columns in this one. So let's just reshape this for the matrix multiplication to be possible. So A2 has 2 rows and 5 columns, and A3 also has 2 rows and 5 columns. We'll augment that into 5 into 2. So this resultant matrix will have 5 rows and 2 columns. And when we do a dot multiplication between the two, we'll have an end output with 2 rows and 2 columns. Let's see. Now if we have A4 printed, we can see this is the matrix multiplication of two matrices with the dimension 2:5 and 5:2. So the end output is an array with 2 into 2 dimensions. We can also do a lot of trigonometric functions. So we invoke the trigonometric functions directly from NumPy. So let's say A5 is equal to np.sin of A4. And we get the resultant value in A5. We can also do A6 as the cos trigonometric function. So we say np.cos and we get the respective values in A6. So as you see over here, we have the resultant values stored in this value in this matrix A6. Now we can also do square operations. So if you remember the old trigonometry rule, sin square theta plus cos square theta is equal to 1. So let's say we create A7 as A5 square. Square is leveraged over here with the double asterisk operator. And then we say A6 square. This is analogous to saying sin square theta plus cos square theta, which is 1, which means that the resultant matrix A7 will have values all 1s. That's it. So NumPy also provides you additional functionalities to create arrays with a single value. Let's say we have something like we want to create an array of 10 elements with all zeros in it. So we'll say np1 is equal to np dot zeros, and we provide the number. Let's say we provide 10. So we have an array of 10 elements with all values as zeros. We can also reshape this to our convenience. And if you want to cast it to a different format, we'll just say dtype is equal to int. If you see over here, the values over here have a data type of float. If you want an integer based array, you can actually create them too. So I can see this np1 will have all zeros. Similarly, we can also create an arrays of all ones. The only change being instead of np.zeros, we call np.ones. And that's it. We can see np1 will have all ones. Similarly, if you want to create an array with a different shape rather than just having the values 10, can we just create with the respective shape? So let's say we have a need for an array of 4 rows and 5 columns with all zeros. So that becomes our np1 array with the respective shape. So in a nutshell, we have explored a couple of basic functionalities offered by the NumPy object and the NumPy package. So if you want to explore further, you can just see what all functionalities are actually provided by the NumPy package. One thing which we missed out was you can actually do a sum of the entire array. So let's say we have the array A1. These are the values. You can say A1.sum and we'll give a sum for the entire array. Similarly, we have min and the max operation too. There are a couple of others I would recommend all of you to explore the NumPy package and see what all different functionalities are offered over here. There are a couple of other elements which we would require, and we would explore them as and when required during the data engineering and data feature engineering process. For now, this would be a comprehensive and basic overview to the NumPy package.